Let's discuss about the terminal velocity. When we drop a spherical ball or a spherical body inside a viscous fluid, it moves inside the fluid with a constant velocity. That constant velocity is called as terminal velocity. Now, when we drop this spherical ball of radius r from rest, initially the velocity is 0, but the acceleration is maximum. When it falls through the viscous fluid, the velocity increases. By that increase in velocity, the viscous force, which is opposite to the motion of the body, increases, and a time comes when the resultant of all forces on this spherical body or a body is equal to 0 inside a viscous liquid. At that time, the body moves with a constant velocity. As the resultant of the forces is equal to 0, there is no acceleration and the body moves with a constant velocity. That constant velocity is called as terminal velocity. Now, to calculate what is the value or what is the expression of the terminal velocity, we will see the forces on it, and the sum total of those forces is equal to 0. So the body moves with a constant velocity, that is terminal velocity. We know that when a body falls inside the liquid, the weight is directly downwards, but when a body is placed in a liquid, it displaces some liquid, by which the buoyant force comes into play. So the buoyant force, the direction of the buoyant force is upwards. Also, there is a viscous force Fv that is directed upwards. So we are having two forces upwards and one downward force. The resultant of those forces is equal to 0. So the body will move with terminal velocity. We will calculate that terminal velocity by equating the weight with some of these two forces. One is viscous force and one is buoyant force. Okay. Now we will see that what is the weight of the body. Weight of the body is m into g. Now the mass is equal to volume into density, that is 4 by 3 pi r cube, as r is the radius of the spherical body. Let rho be the density of the body. The weight will be equal to 4 by 3 pi r cube into rho into g. So we have got the value of the downward force, that is mg, that is equal to 4 by 3 pi r cube rho into g. Similarly, the buoyant force is the weight of the liquid displaced, that is equal to m into g, where m is the mass of liquid displaced, that is volume of liquid displaced 4 by 3 pi r cube into sigma, where sigma is the density of the liquid into g. So we have got the buoyant force as well. We will calculate Stokes' law. The viscous force is equal to 6 pi neta r v, where neta is the coefficient of viscosity, or is the radius of the spherical body, and v is the velocity. This v is the terminal velocity. Now we will equate. As we know, the weight of the body is equal to the buoyant force plus the viscous drag force. Now we will equate these two and we will get the relation for the terminal velocity. Now here we have 4 by 3 pi r cube into rho into g, that is equal to 4 by 3 pi r cube into sigma into g plus 6 pi neta r v. Taking this side, so 4 by 3 pi r cube into g is common, that is rho minus sigma is equal to 6 pi neta r v. Now this pi and pi gets cancelled, 1 r and 1 r gets cancelled, giving us 2. So this is equal to 4 by 18 into r square into g into rho minus sigma equal to neta into v. So the terminal velocity equals to, dividing it gives us 2 by 9, that is 2 by 9 into r square into rho minus sigma into g divided by neta. This is the expression for the terminal velocity. So the expression for the terminal velocity is v is equal to 2 by 9 into r square into rho minus sigma into g divided by neta, where neta is the coefficient of the viscosity, r is the radius of the spherical ball, rho is the density of the body, sigma is the density of the liquid. We have the velocity is directly proportional to r square, and velocity is inversely proportional to neta. That means more is the radius of the ball, more is the terminal velocity, less is the coefficient of the viscosity, more is the terminal velocity, more is the coefficient of viscosity, less is the terminal velocity. If we have to compare the terminal velocities of two balls having different radii, in that case we have v1 by v2 is equal to r1 square divided by r2 square. If we have to compare in their coefficient of viscosities of two liquids, the terminal velocity will be given as v1 by v2 is equal to neta 2 divided by neta 1, as the terminal velocity is inversely proportional to neta. The terminal velocity can be negative. The value of the terminal velocity can be negative when the value of density of the fluid is greater than the density of the density of the spherical balls or density of the material that is moving with the terminal velocity. In that case, the value of the terminal velocity is negative. That means the direction of terminal velocity is upwards. That is why the gas and the air bubbles move up inside a liquid. Relation between V and S, the velocity and the distance. In the case of body moving, terminal velocity is given as, here we have velocity, here we have distance, that is this. That means after some time, when firstly with the distance the velocity increases, and after traveling some distance the velocity becomes constant, because after traveling some distance in the viscous liquid, the body or the spherical body moves with the terminal velocity, and that terminal velocity is constant. Thank you.